Hello, it's Scott Manley here. Today, I want to start a new series called Deeper Space Questions. This is basically a follow-on to Deep Space Questions. That was where I would take questions from my supporters over at my Patreon, and then I would attempt to answer these lightning round style without any reference to actual research materials. And some of these were really dumb, some of them were quite smart, and some of them were things that I really wanted to make into full long-form videos. And so the Deeper Space side is going to be, we do a bit more research and I'm a bit more selective. And we're going to start with a question from Gregor Shapiro, who's asking, which moons and planets could be explored with helicopters or aerostats? So really what I want to focus on is atmospheric exploration. Aerostats being lighter than air balloons or airships and things like that. And helicopters, yes, we know about that. So obviously, we've had a few examples of these already in the solar system. We've had the Mars Ingenuity helicopter, which flew around, and Mars does have a very thin carbon dioxide atmosphere. Its equivalent pressure is like equivalent to the Earth up at around 80,000 feet. So it's a vacuum as far as the human body is concerned, but there's just enough gas there that aircraft can in fact use it. Venus is another one which has actually been explored, and that was explored by the Soviet Vega spacecraft. There was two of them, and they deployed balloons into the atmosphere. Now, if you look further afield, we have atmospheres which have only been explored with parachutes. We have Titan, that is the moon of Saturn, which has a very thick atmosphere, and because its density is high enough and Titan's gravity is low enough, it's actually the one place in the solar system where humans could actually fly if they strapped wings to themselves, like in terms of the power density that you can produce from your arms or whatever. You could in theory fly on Titan, but you'd be very, very cold. Jupiter, it has also been explored by an atmosphere probe which descended through the atmosphere, and I have a fine video on that you should take a look at. It was the most insane atmosphere entry in space exploration history. And so obviously Jupiter, Saturn, Uranus, and Neptune, they all have thick atmospheres that could be explored. Those are the main ones. Now, there are atmospheres on most planets that we've looked at. It's just mostly the atmospheres are far too thin to be useful for like lift. Like you can detect that there's some gas that is attached to the planets, such as Mercury, for example, has an atmosphere that contains a fair amount of sodium, which we don't think of as gas, but when you're that close to the sun, lots of things become gases and liquids. The moon actually has a very, very thin, tenuous atmosphere, which increases when spacecraft land on it. Like the amount of exhaust that comes out of a spacecraft is enough to noticeably change the amount of gas in the atmosphere of the moon. So what are the advantages of exploring planets with these aircraft? And I really want to focus on balloons, to be sure, or lighter than air. So it lets you do in situ measurements of the atmosphere. Now, we can indeed have spacecraft and telescopes that look at atmospheres and we can see things that are in there, we can detect spectra. But if you put an instrument into the atmosphere, it can start using mass spectroscopy to start looking at isotope ratios, for example. This is where two different versions of a particular element, the ratios can actually tell you a lot about where they came from in the solar system, and it can take give you information on formation processes. You can get direct measurements of atmospheric motions. We can get broad scale versions of those again from space, but if you're actually putting aircraft in there, they are feeling that air blowing them around. By flying in the atmosphere, you can get aerial surveys from a much lower altitude. You might be able to get below cloud layers, for example, on Venus, or simply on Mars, you might be able to just photograph the surface from an altitude which is somewhere between high orbit and on the surface. These are all the kind of advantages. So let's talk about the sort of first aerial exploration of Venus. And that would be Vega 1 and Vega 2. And these were unmanned, spacecraft launched in December of 1984. It was the Soviet Union, and there was also some European nations like Austria, Hungary, and stuff like that. And this was actually a multiple objective mission. This spacecraft, it not only put balloons into the atmosphere of Venus, it put landers on the surface of Venus, and spacecraft that flew by Venus and went on to visit Halley's Comet. So Vega 1 and Vega 2, they were pretty much the same. They would land this descent, the descent unit would fall through the atmosphere, and then it would deploy this balloon. They were called aerobots, and they were designed to fly around 54 kilometers up above the surface. This is sort of the most active area of the Venusian cloud system. And they were simple, like spherical super pressure balloons, which means that they would actually be self-contained. There was no leaks or anything, not like a hot air balloon, which may have a vent that comes in from the bottom. The balloons were about 3.5 meters in diameter, filled with helium, and there was a gondola that hung underneath it that was about 7 kilograms, right? And they would be hanging out by like a tether, maybe like 30, 40 feet long. So you would have like an antenna on this, and it would be measuring various like scientific stuff. You had like photodiodes, thermometers, you could obviously have salt batteries and stuff like that, a nephelometer to measure the amount of clouds. And the signals from these, they had to get picked up on the Earth. There was like a continuous observation by something like 20 different radio telescopes, because these things were on battery power and they would only last for a few days. They only lasted, I believe, for 48 hours. But the data was actually collected. They started on the dark side, but very quickly moved around to the light side. And they provided, a whole lot of information on Venus's atmosphere. And that's the only time that humanity has ever done that. Now, interesting thing about Venus, by the way, is that while the planet takes a long time to rotate, like hundreds of days, the atmosphere is actually pretty fast. And if you're floating in the atmosphere, you're going to complete one trip around the planet like every 5 days or so. It's kind of wild. And this led to one particularly high-profile NASA study, which was never really intended to be a mission, but it was a really fascinating, exercise in spacecraft design. It was something called HAVOC, right? This is basically, let's explore Venus with airships. And not only that, let's actually have crew fly down into the atmosphere and spend like a year cruising the skies of Venus, doing research, and then before flying back into space. So this was called HAVOC, High Altitude Venus Operational Concept. And, it was, again, mostly a study. It was never seriously intended to happen, to be a real thing, but it was, something that definitely grabbed people's attention. And you'll see people talking about how it's easy to colonize Venus, because while the surface of Venus is hell, it is like not compatible with human life in any way. As you go higher and higher, the temperatures get lower and lower. And around the 1 atmosphere level, there's a point where the temperatures are sort of reasonable, the pressures are sort of reasonable. And the only problem really is that, you can't breathe carbon dioxide, and that's what most of the atmosphere is. Interesting point, by the way, if you're talking about lighter than air, if you have an oxygen, nitrogen atmosphere that humans can breathe, then that you can actually make a balloon with that and it will float in carbon dioxide, because carbon dioxide is heavier. But yeah, if you were to build an actual airship for humans, you would probably have helium in there as well. So we've already. I don't actually want to focus so much on helicopters, because I've done some videos on those, to be honest. But for most of these places, yes, you could in theory fly helicopters, and other like fixed wing aircraft would be another option. The problem that we have to deal with is that with helicopters, the energy density that is expended to keep them airborne generally precludes maintaining altitude for any serious amount of time. So if we looked at Ingenuity, they would fly for a short amount of time and then land and recharge. And we're going to see the same thing for Dragonfly, which is going to Titan. We can talk about that later. It's going to have to spend like days, weeks charging up and then fly for a few minutes or more. That's not going to work on Venus, because as soon as you cut off your power, you're going to sink down into the clouds and get destroyed. But you could have a fixed wing aircraft that flies under solar power. So again, atmosphere on Venus is slightly denser than the Earth. The gravity is a little lower and the sunlight is brighter. So we had an aircraft which flew around the world with a person in it. We've had an aircraft that also flew under solar power for long periods of time. It was able to recharge it was able to recharge during the day and run on battery power at night. You could build exactly the same kind of thing and it would work brilliantly in Venus. It probably wouldn't work in any other atmosphere because the amount of solar power available to sustain flight just isn't there. But Venus is one place where you could actually have a heavier than air aircraft which maintains altitude and never needs to land. It would have to somehow deal with the fact that it had to spend maybe 3 days at night, so its batteries might have to be bigger. But again, it's thicker atmosphere, and higher power densities, so it's entirely possible that it could survive. Or maybe it just sits around at the poles, right? That's another option. But the lighter than air, that offers a lot more options for many things. So if we're talking about lighter than air aircraft, there's really two kinds. You've got the sort of super pressure balloons where you have a lifting gas which is all contained, and then you have zero pressure ones where you take basically atmospheric gas and you heat it up, and it floats up. And so this is the kind of balloon that Montgolfier brothers developed. We've seen those pictures, pre-French Revolution. They have this beautiful crafted silk balloon and a fire underneath it. And that first flight, we see these pictures of this. That first flight, that actually happened before the French Revolution. I believe Marie Antoinette was in the audience watching this. And I believe also complained about the smell because the Montgolfier brothers, they didn't understand that it was the heat that was causing the air to become buoyant. They thought it was like special gas that was being given off by whatever they were burning. And they'd experimented and they'd come up with that damp stuff actually seemed to fly better. So they were burning really nasty smelling stuff like rotting straw, rotting meat, shoes. It stank terribly, but it did actually fly. I think the thing is, if you have a lot of moisture in the smoke, it actually helps because first of all, water vapor is lower density than oxygen and nitrogen, so it is lighter. But also, as it condenses out, it releases its latent heat of vaporization, and that will keep the oxygen and the nitrogen warmer longer. So there was like a grain of truth to that burning these nasty, damp smelling stuff would actually keep it burning or keep it floating longer. But obviously the Montgolfier brothers, they pioneered this idea of the hot air balloon. And I think in the 70s and 80s, the CNES, the French space agency, they actually began to pioneer what they called Montgolfier type balloons. This was a project to build solar balloons that would float in the upper atmosphere for a long time. We have helium balloons. We see those all the time. It's very easy to make those. But you can make a self-sustaining solar balloon, which just takes, is buoyed by the heating of the sun. And actually, interestingly, on the Earth, it's not the sun that heats them. So if you imagine, right, if you've got a balloon in the high atmosphere, the surface of it interacts with the sun differently than the air around it. So it'll actually transfer heat to the gas inside it. And that means that if you have like a black bin bag, a black trash bag, and you seal it up and you make it big enough and take out on a sunny day, it can just fly away on its own because of the heat of the sun. The trick is then keeping it up there for a very long time because if you know about albedo and emissivity, you'll know that black surfaces not only absorb heat really well, they emit heat really well. So if you have like a simple black bag, it's going to cool down too quickly and descend at night. So to make these Montgolfier type balloons fly, they would actually have a balloon where it was like opaque on the top and it would be transparent on the bottom. And on the top, it would be silvered. And inside, it would be black. And the idea was it wasn't really getting heated from the sun's light. It was getting heated from the reflected or the re-emitted thermal radiation from the Earth. So the heat coming back upwards. And that would be there at night as well as during the day. So they would maximize this, and by having the silver top, they would reduce the emissivity so they could keep this flying for a long time. And guess what? This concept absolutely makes sense for a whole bunch of places. This can work on Mars. People have done the math. Yes, it can in fact work. But more interestingly, it could work on Jupiter. You could have these Montgolfier type balloons floating around in Jupiter for a very long time if you figured a way to actually deliver them. And Jupiter is actually one of the best ones because Jupiter emits a lot of thermal radiation from down below because it's a gas giant. The Jupiter is contracting as it gives up energy to space. So it's actually emitting more thermal radiation than it takes in from the sun. So these kind of Montgolfier type balloons could actually work. The hard part is, of course, deploying a balloon after you've descended through the atmosphere and you're falling towards, deep into the depths. It is absolutely possible. In fact, I saw a thing about like a electronic warfare munition that was developed in the 80s. It was like a fuel tank sized thing that would get dropped from an F-111. And as it dropped, it would deploy a balloon, and then this balloon would hang around for like a day or so doing electronic warfare, like, hitting things with radar and jamming stuff. So US military absolutely developed ways of deploying balloons that were falling from the sky. So totally would be doable. So that was one idea. Now, the interesting thing about this then is, how do you power them? And the obvious way is to power them with radioisotope thermoelectric generators. Now, again, these things are creating waste radioactive heat, which flows through thermocouples, which generates electrical power. And the typical problem is they generate a lot of heat and very little electrical power. That's not such a big deal when you actually need lots of heat to help your gases work. So you can augment the solar heating with an RTG. Jupiter's also great because its day is only 10 hours, so you only spend like 5 hours in darkness. But there was another project called Aerobots, or Windbots, and this was a notion that you could take advantage of wind shear in Jupiter. So there is actually measurable wind shear that was captured by the Jupiter Atmosphere Probe. And the idea, if you're just floating in a bundle of air, there's no energy there. But as soon as the wind changes for you, as soon as you flow from one wind section to another, there's a wind shear, and you can actually harness that power to generate electrical power. And this was a NIAC, NASA Innovative Advanced Concepts project that was studied a few years ago, and they came up with various ways that were very similar to self-winding mechanisms on watches, but they were driven by airflows. There's other ideas, by the way. If you have two different wind shear things, you can use what's called dynamic soaring, where you basically fly circles in and out of each thing and build up speed. People build model gliders which get to like 500 miles an hour by using dynamic soaring near hilltops. Like, the speed records for model aircraft are held by gliders doing this kind of stuff. It's absolutely wild that this happens. So yeah, these kind of balloons work very well on Jupiter. The thing about Jupiter, by the way, is that because its atmosphere is hydrogen and helium, it's very hard to have like a lighter than air gas. Normally we put helium in our balloons here, but if you make a helium balloon on Jupiter, it will sink because it's heavier. Jupiter's atmosphere is 75% hydrogen, 25% helium. So you could actually make a hydrogen balloon on Jupiter, and it would have about the same lift per unit, cubic meter or whatever, as a helium weather balloon does on Earth at 100,000 feet. So actually that is doable. But the fascinating thing about this is that they have the reverse problem of balloons on Earth. Balloons on Earth, because helium is one of these slippery molecules, it just like finds its way through the skin of the balloon, and the balloon slowly loses its helium until it descends to the Earth. Either that or the balloon goes too high and it pops. But the balloons can't stay up there forever because the helium is slowly diffusing outwards. On Jupiter, it's the reverse problem. You have a hydrogen balloon and the helium is diffusing in and making it less buoyant. So you'd have to come up with some mechanism to selectively remove the helium and retain the hydrogen. And by the way, such technology is being studied, because you need that if you want to run a fusion reactor. If you're running a fusion reactor, you're turning hydrogen into helium and you want to remove the excess helium over time, right? So technologies are out there if you want to look at them. Yeah, so there was a pretty serious study to look at a Mars balloon as part of like one of the Mars Science Lab missions. This was back before Ingenuity was a real thing. This would look at, it was going to be like a 3-month mission. It would be released from a larger spacecraft. The whole thing, the balloon would be about 55 kilograms. The lifting gas would be 12. The payload that would be carried was another 15. So you've got like a 100-kilogram probe. And this would be a fairly robust envelope filled with hydrogen or helium. Interesting thing about Mars, by the way, is that while they had to fill the inside with helium, they still had to paint the top silver, because if it was black, if it was emitting too much heat, it would cool down too much at night, and you could have carbon dioxide start to freeze out on the surface of the balloon and cause it to sink. So they needed to account for that. The kind of balloon they had was a multi-layer design with like mylar on the inside. It would have like a Kevlar scrim, like a mesh material to make it strong, and then polyethylene on the outside. And, you need this because you want to have a balloon that is robust. You don't want to have something that gets a tiny pinprick, and then that pinprick develops into a tear, and the tear eventually propagates. So having things like the Kevlar scrim stops this kind of thing. Again, the kind of engineering that you need to study. Yes, I think the Montgolfier-style balloons are the best bet for things with gas giants, but it becomes harder to do it at Saturn, Uranus, and Neptune because the amount of sun is less and the amount of heat coming out of the interior is less. But it's still doable if you want to do that. Obviously, I think Jupiter would be the first place you'd do this. I don't think you can have like a fixed wing aircraft on Jupiter flying for any serious amount of time because you would end up with a situation where it just doesn't have the energy density. But you could do something like an airship, and that would actually be completely valid because you could then use the power to actually run props and actually make it fly around. So it could perhaps explore a larger part of the planet. With Jupiter, you would tend to be stuck in one of the particular bands. You wouldn't tend to go very far north or south. You would just go around the planet. So you would need some active propulsion to be able to explore different regions on the world. So yeah, I'm trying to think what else there is in this situation. So obviously I've mentioned Dragonfly. Titan's great because, you can send Dragonfly down there, and you could actually design a balloon which floats just below the clouds and could actually see down to the surface. Also, by the way, there was a Soviet scientist who looked at balloons on Venus, and one of the things he came up with was a balloon that was filled with water. And if you look at the temperature at which water begins to vaporize, it's about 41 kilometers. So you could have a balloon that more or less sits at about that altitude. If it falls down, then more water vaporizes and it becomes more buoyant. If it gets higher, the water condenses out and it sinks, right? So it would be stable around 41 kilometers, which is just below most of the clouds, but still in a sort of sulfuric acid haze. But you could build a spacecraft that's designed to sort of float below the clouds and just take pictures of the surface and get really high quality, satellite imagery, albeit through the haze. I'm not sure just how thick that haze is, but that was a worthy idea. So yeah, I think we've covered all the places we could explore with helicopters and balloons and planes and stuff. Fascinating possibilities of technology. And if you have similar questions that you want answered, please go over to the Patreon, sign up, ask questions. I'm Scott Manley. Fly safe.